Hello, welcome to 4.2 Polynomial Division and the Division Algorithm. Okay, the division algorithm. Let P and D of x be polynomials such that D of x is not equal to 0 with a degree of D less than or equal to that of P. So P for polynomial, D for divisor. Think of that. Then there are unique polynomials Q of x, Q for quotient, result from division, and R of x, think of that for remainder. Called the quotient and remainder respectively such that P of x equals Q of x times D of x plus the remainder. And this isn't too dissimilar from saying, okay, let's see, 5 goes into 11 2 times with a remainder of 1. You could write 11 equals Q of x 2 times D, our divisor, 5 plus the remainder, which is 1. You could think of it that way. The degree of the remainder R is less than the degree of the divisor, or else the remainder is 0. In which case we say D divides evenly into the polynomial P. If the remainder is 0, the two polynomials Q and D are factors of P. If one polynomial is divided by another of smaller degree, the result is a polynomial plus possibly, it should say ratio, not ration, of two polynomials, the numerator of which has a smaller degree than the denominator. Zeros and linear factors. The number k is a zero of a polynomial p of x if and only if the linear polynomial x minus k is a factor of p. In this case, p of x is q of x times x minus k for some quotient polynomial q. This also means that k is a solution of the polynomial equation p of x equals 0. And if p is a polynomial with real coefficients and k is a real number, then k is an x-intercept of p. So k being a 0 means that x minus k is a factor. That means p of k is a 0, and it means that k comma 0 is an x-intercept. The remainder theorem. If the polynomial p of x is divided by x minus k, the remainder is p of k. That's a really cool result. You can go through all the work of plugging this in, or you can just do the division and the remainder is what you get for plugging it in. So example 1 says, use polynomial long division to rewrite each of the following fractions, not fractions, but fractions, a lot of typos here, in the form q of x plus r of x divided by d of x, where d of x is the denominator of the original fraction, not faction. Q of x is the quotient and r of x is the remainder. So here's our divisor. X plus 2 goes into 5x squared plus 9x minus 6. X times what is 5x? Okay, it's going to be 5x. It's 5x squared plus 10x. Now when I do my subtraction here, I put it in parentheses because I'm reminding myself everything in the second row is being subtracted from the previous row. You get negative x minus 6. X times what is negative x? That'd be minus 1. So it would be negative x minus 2. I'm going to subtract. Negative 6 minus negative 2 is a negative 4. So our result will be 5x minus 1, that's the quotient, plus negative 4, the remainder, over x plus 2, the divisor. X plus 2 is the divisor, negative 4 is the remainder. We go on to the next page. $35x to the fourth plus the quantity 14 minus 10i x cubed minus the quantity 7 plus 4i x squared plus 2ix divided by 7x minus 2i. Okay, 7x times what is 35x to the fourth? And that would be 5x cubed. 5x cubed times negative 2ix is negative 10ix cubed. When we subtract, 35x to the fourth minus 35x to the fourth is nothing. The negative 10ix cubed minus 10 minus a negative 10ix cubed is 0. So we bring down our 14x cubed. And then bring down this next term minus the quantity 7 plus 4ix squared. In fact, I think I'm going to just distribute that. Minus 7 minus 4ix squared. Sorry, minus 7x squared minus 4ix squared. Now 7x times what is 14x cubed, and that would be plus 2x squared. So 14x cubed minus 4ix squared, and we subtract. And we have just a minus 7x squared plus 2ix. 7x times what is negative 7x squared? Minus x. So minus 7x squared plus 2ix, that's from the negative x times minus 2i, and we end up with 0. So the answer here is just 5x cubed plus 2x squared minus x. And I really want to encourage people not to let imaginaries or complex numbers in this case intimidate you from doing the problem. It's still very doable. Okay. We go on to the next problem here. We have 9x squared minus x minus 1 goes into 9x to the fifth minus 10x to the fourth plus 18x cubed minus 28x squared plus x plus 3. Whew! 9x x squared times what is 9x to the fifth, and that would be x cubed. And again, notice, I didn't say this before, but notice I wrote it's x cubed over the x cubed term. X cubed times 9x squared is 9x to the fifth. X cubed times negative x is minus x to the fourth. X cubed times negative 1 is minus x cubed. We're subtracting. 9x to the fifth minus 9x to the fifth is nothing. Negative 10x to the fourth minus a negative x to the fourth is negative 9x to the fourth. 18x cubed minus a negative x cubed is plus 19x cubed. I'll bring down the next term, minus 28x squared. 9x squared times what is negative 9x to the fourth? That would be negative x squared. So negative x squared times 9x squared is negative 9x to the fourth. Negative x squared times negative x is minus x cubed. That's plus x cubed. Negative x squared times negative 1 is plus x squared. Subtract, we're going to end up with nothing here. 19x cubed minus x cubed is 18x cubed. Negative 28x squared minus x squared is minus 29x squared. Bring down the x. 9x squared times what is 18x cubed? Plus 2x. 2x times negative x is minus 2x squared. 2x times negative 1 is minus 2x. So I'm going to have negative 27x squared plus 3x plus 3. 9x squared times what is negative 27x squared? That's negative 3. Negative 3 times negative x is 3x. Negative 3 times negative 1 is 3. we're subtracting, so hey, look at that, a remainder of 0 again. So our answer is x cubed minus x squared plus 2x minus 3. It's fun when things work out like that, when we have a 0 remainder. Okay, I'm going to go on to the next page. Now I did copy this out of the book. Synthetic division. I think I got this out of this book. I used a book once that had a really bad synthetic division breakdown. Okay, and even this is not that clear of a process. Synthetic division is, it works, it's great. It's when you have a linear factor leading coefficients of 1. So f of x equals ax to the n, all that kind of stuff, divided by x minus k. Now the k goes in the little box. So notice that x minus k goes in the box. Just the k goes there. So if it's x minus 2, 2 would go in the box. If it's x plus 5, negative 5 goes in the box. Put in the box, you have all the coefficients for the x's across the top. And it's not going to be that big. You're not going to have 10 terms up here. So you always start with a 0. First number plus 0 is whatever down here. Then you do this number in the box times that number goes in that spot. And you add straight down again. This number times that one gives you that spot. Add straight down until you get to the end. Your last number is the remainder. Let's do some synthetic division. And this is a really good tool to have, and we're going to be using this a lot in the rest of this chapter, especially 4.3 and so on, that when we're trying to find zeros of the polynomial, this is one of the tools we have at our disposal. Okay, so we have p of x equals 32x to the fifth minus 80x to the fourth plus 80x cubed minus 40x squared plus 10x plus 2, and k is 1/2. So we're going to put 1/2 in a little box. I didn't even read the directions. Use synthetic division to determine if the given value for k is a 0 of the corresponding polynomial. If not, determine p of k. Well, p of k is just our remainder. So if it's 0, it's a 0. If it's not 0, that's a remainder. So 32, negative 80, positive 80, negative 40, positive 10, and then a 2. 32 plus 0 is 32. 1/2 times 32 is what? 16. So let me stress that. I did a 1/2 times 32 made us the 16. We add straight down, we're going to have negative 64. Then we do 1/2 of 64 is negative 32. We're going to have 48. 1/2 of this 48 gives us 24. Negative 40 and 24 is negative 16. Half of 16 is our negative 8. So we get 2 from that. Half of 2 is 1. Well, 2 plus 1 is 3. This is the remainder. So p of 1/2 equals 3. So 1/2 was not a 0, and its remainder, if you plugged it all the way through, it's going to be 3. For the next one, p of x equals x squared minus 6x plus 13. K is 3x minus 3 minus 2i. Now, this can be a little more complicated because we have complex numbers. So we're going to have 1, negative 6, and 13. Give myself some space here. One plus 0 is 1. 3 minus 2i times 1 is 3 minus 2i. Negative 6 minus 3 minus 2i. This is negative 6 minus 3 minus 2i. It's negative 6 minus 3 plus 2i. And that's going to be negative 6. Oh, sorry, this is a plus between them. Plus 3i, 3 minus 2i. There we go. Negative 6 plus 3 is negative 3, and then minus 2i. So the result from right here, we're adding straight down, is negative 3 minus 2i. Now we're going to be multiplying. 3 minus 2i times negative 3 minus 2i. You might see something here. You might see, oh, I can factor out the negative 1 and it's an a plus b, a minus b. In case you don't, we can always FOIL this out. 3 times negative 3 is negative 9. 3 times negative 2i is minus 6i. Negative 2i times negative 3 is plus 6i. Negative 2i times negative 2i is plus 4i squared. The middle stuff, of course, goes away. We have negative 9 minus 4, or negative 13. So by multiplying 3 minus 2i times negative 3 minus 2i, we get negative 13. Add that up, we get 0. So that's our remainder. Remainder is 0 here. So 3 minus 2i is a 0. Oh, and it's pretty standard to put a vertical line at the last column to designate your remainder. And p of 3 minus 2i equals 0, if you want to see that. Okay, I'm going to go on to c, so pause if you need to pause that. Okay, p of x is x to the fourth minus 3x cubed minus 3x squared plus 11x minus 6, and k is 1. So 1 goes in the box. 1 minus 3 minus 3, 11, and negative 6. One times 1 is 1. Negative 3 and 1 is negative 2. 1 times negative 2 is negative 2. Negative 3, negative 2 is negative 5. 1 times negative 5 is negative 5. 11 and negative 5 is 6. 1 times 6 is 6. Negative 6 and 6 is 0. So 1 is a 0. P of 1 must be 0. This also means, if you're curious, let me just show you a little thing how to relate back to what we have. This would now be what we call a constant. This is your x term, x squared, x cubed. Notice I'm building up from the constant. So what you would really have then is that the original polynomial, x to the fourth minus 3x cubed minus 3x squared plus 11x minus 6 factors to be 1 times x cubed minus 2 times x squared minus 5x plus 6 times x minus 1, because 1's a 0. So this factors to be that polynomial, that product. Just a side note, we didn't have to do that for the problem, I just want to share the information. Okay, I'm going to go on to example 3. It says, use synthetic division to rewrite each of the following fractions in the form q of x equals r of x, q of x plus r of x over d of x. Okay, so I'm going to put 2 in the box. What do we have here? Negative 2 is the leading coefficient, plus just a 4, then a 3, then a negative 7, then a 3, and then a negative 2. Negative 2 and 0 is negative 2. 2 times negative 2 is negative 4. We get 0. 2 times 0 is 0. We get a 3. 2 times 3 is 6. Negative 7 plus 6 is negative 1. 2 times negative 1 is negative 2. 3 and negative 2 is 1. 2 times 1 is 2. We get a 0. So this means we can write this as the following. This is our constant. This is x. This is x squared, x cubed, x to the fourth. This result would be negative 2x to the fourth plus, there's no x cubed, so we can say 0x cubed plus 3x squared minus x plus 1. Or we can say 2x to the fourth negative plus 3x squared minus x plus 1. on to the next problem. We have x to the fifth minus 3x to the fourth plus x cubed minus 5x squared plus 18. Now notice here, there's no x term. So 3 is going to go in the box. Remember, it's x minus 3, so it's 3 goes in the box. If it's x plus 3, it'd be a negative 3 in the box. So we have 1, negative 3, 1, negative 5, 0 because there's no x term. So 0 there, then 18. 1 plus 0 is 1. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. 1 plus 0 is 1. 3 times 1 is 3. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. 0 and negative 6 is negative 6. 3 times negative 6 is 18. Hey, we get a 0. Negative 18, I should say. We get a 0. So again, we have our constant, our x term, x squared, x cubed, x to the fourth. And notice here, I didn't mention this before, the highest degree now is x to the fourth. It was x to the fifth. Well, x to the fifth divided by x is x to the fourth. Not a coincidence there. This comes out to be x to the fourth plus x squared minus 2x minus 6. Okay, I'm going to go on to the last example here where we're going to construct some polynomials. We're going to construct a polynomial function with the stated properties. So I'm going to scroll this up, give me a little more space to work, not a lot more, but a little bit more. Construct a polynomial function with the stated properties, third degree, zeros of negative 2, 1, and 3, and a y-intercept of negative 12. This is how you do it. So our polynomial, it's going to be a, some leading coefficient, could be 1, times x minus negative 2 times x minus 1 times x minus 3. Now we're told the y-intercept is negative 12, so you could look at p of 0 because x is 0 at the y-intercept, is a times 0 minus, or 0 plus 2, I should say, times 0 minus 1 times 0 minus 3, and that's got to be negative 12. So a times 2 times negative 1 is negative 2, times negative 3 is positive 6. So a times 6 is negative 12, so a equals negative 2. So p of x is negative 2 times x plus 2 times x minus 1 times x minus 3. Now what I'm going to want you to do on this, and also on the exam, is to multiply these out. So p of x is negative 2 times x plus 2 times x minus 1 is going to be x squared plus x minus 2 times x minus 3. I'm going to multiply this out, x squared times x, x cubed minus 3x squared plus x squared minus 3x minus 2x plus 6. It's x cubed minus 2x squared minus 5x plus 6. So if I distribute the negative 2 through there, it's going to be negative 2x cubed plus 4x squared plus 10x minus 12. Okay, and then for the last one, third degree, zeros of 1 minus I, 2 plus I, and negative 1, leading coefficient of negative 2. Okay, that's a little less work in part of it. So our p of x is going to be negative 2 times x minus the quantity 1 minus I times x minus the quantity 2 plus I times x minus negative 1. So if I FOIL this first part, that's going to be x squared minus the quantity, let's see, x times negative 2 plus I, I'm going to say that's minus 2x minus ix. And then we have the negative of 1 times x is minus x. Negative of negative I is plus I times x is plus ix. And then we have the negative of 1 times 2 times negative 2 is going to be plus 2. Negative of 1 times negative of I is plus I. Negative of negative I, that's I times negative 2 is minus 2I. Negative of negative I is I times negative I is minus I squared. We still have an x plus 1 out here. It's x squared. Now stuff will go away. We have this minus ix and the plus ix. And that might be it. We have plus I minus 2I of plus 2. Okay, so x squared, we have minus 3x from here. And then we have 2. Now negative I squared is going to be 1 because I squared is negative 1. So 2 and 1 is 3. So plus 3 minus I times x plus 1. Now we're going to multiply this through. We still have a negative 2 out front times x squared times x is x cubed. X squared times 1 is x squared. Negative 3x times x is minus 3x squared. Negative 3x times 1 is minus 3x. 3 times x is 3x. 3 times 1 is 3. Negative I times x is minus ix. Negative I times 1 is minus I. So our p of x is negative 2 times what? Well, this minus 3x squared, minus 3 and plus 3, they're going to go away. So we have x cubed plus x squared. No, sorry, minus 2x squared looks like. Plus, see, minus ix plus 3 minus I. Then multiply everything by that negative 2, and we end up with negative 2x cubed plus 4x squared plus 2ix minus 6 plus 2I. I want to double check the negatives. So negative times positive, good. Negative times negative is positive. Negative times negative is positive. Negative times positive is negative. Negative times negative is positive. Okay, I think that looks like it's about it. Yep, that's it. Okay, we are good. Okay, and that'll do it for 4.2, polynomial division and the division algorithm. So send me your questions. Thank you.